So in this video we'll be going over RREF, which is known as Reduced Row Echelon Form, and I highly recommend that you check out my other video which is on RREF, as they both are quite similar, and knowing REF will help you understand RREF. So the conditions are the same except that every pivot has to be 1 and there cannot be any digit below it and above it. So in the first example that we have, the first pivot is 1 here, and we check for any non-zero elements below it, which there aren't any, and we look diagonally again, so down and to the right, and the next pivot in the second row is 1 also, and there is nothing above it and below it, and by that I mean there's no non-zero element above it. So let's say if this 0 was 1 here, then this will violate the condition and this will be in REF instead of RREF. So in our case it is 0, so it is in REF. And let's move on to the next matrix here. First pivot is 3, so you already know that this is not RREF. And next pivot is 1 here, diagonally, so down and to the right, and last row pivot is 1. And now let's look up and down. So there's we already know that it can only be REF, so below 3 is 0 and 0, and below 1 here is 0, so this is in REF. Let me just write it here. And for the next matrix here, the first pivot is 1, and the second pivot is also 1, and there is nothing above this pivot and below this pivot, so this is in RREF. Our next example here is so this is the first pivot. Below and to the right is this pivot, and we have a non-zero row here, zero row here, which again it has to follow that condition that it has to be the last row, and which in our case it is. So this is in RREF. Our next example here is, this is the first pivot, this is the second pivot, and there is again a 0 row here, which is the bottom, so this is also an REF. And our last example here is that there is only one pivot here and there's nothing below it and above it, so these three are in RREF, the last three RREF, sorry. So now let's see how do we convert a matrix into RREF. So here we have a 3 by 4 matrix, as you can see, and the first step again will be identifying the pivot in the first row. So as we can see, it is 3. So our best, first of all we need to convert this into 1, and we can see that the row is not divisible by 3, so if we do that we will end up with fractions which will complicate it too much. So we can see that the second row has a 1, so what we can do is we can exchange these two rows. So what I mean by that is we switch R1 with R2, and this will give us this, and our next step will be to do minus 3 R1 plus R2, which will give us this. And if we identify the pivots again, we see that we have 1 and 5 in the second row, so we need to change this 5 into 1, and we have no other choice but to have fractions here, since we have to divide the entire row by 5, and this will be 4 over 5 and 4 over 5. And let's do that now. So we divide row 2 by 1 over 5, and we can see that there is a 4 in row 3, and we divide that by 1 over 4 to convert it into 1. And now we have the 3 pivots, but there are numbers above it, so we need to get rid of these numbers which are highlighted in red, and we do that by having some operations again. So we do R2 plus R1 to get rid of that -1, so we will have this matrix remaining, and we can see that there we need to get rid of this 4 over 5 here and this 4 over 5 in row 1 and 2, and we do that by adding again the row 3 of operation of these two. So negative 4 over 5 R3 plus R1, and then negative 4 over 5 R3 plus R2. And the final answer we will get is this, and we can verify the pivots by highlighting there's one here in the first row, second row, and third row, and there is no numbers above it and below it. So let's move on to another example of RREF. So here we have a 3 by 4 matrix again, and our first pivot is 2, and we can see that the first row is divisible by half, so we can convert this 2 into 1, and let's do that then. So 1 over 2 R1 will give us this matrix, and now we need to get rid of this 2 here and this 4 here, so we will do the following operations, which are minus 2 R1 plus R2 to get rid of this 2 here in the second row, and minus 4 R1 plus R3 to get rid of this 4 in the third row, and this will give us the matrix of this here. And we notice that the second row is divisible by negative 1 over 3 to convert this negative 3 into 1 for our pivot as 1. So let's do that now. And we get this matrix after dividing the second row by negative 1 over 3. And now we can get rid of 4 here and negative 6. And I have highlighted them in red. So to do that, we basically do the following operations, which are minus 4 R2 plus R1 and 6 R2 plus R3. And we get the following matrix as this now, and we can divide the last row by negative 3. So we do minus 1 over 3 R3, which will give us this matrix. And now the last step which is left is to get rid of the numbers highlighted in red here, and we do that by doing minus R3 plus R2 and 2R3 plus R1. And this is the final matrix in RREF form, and we can verify by checking the pivots and any numbers below and above it. And yeah, so that's all for this video.